Hello everyone, this is Math 145, day 12. We're talking about lesson 10, the second half of it, which is concerned with navigational bearings. So, more word problems, but all about navigation. And there are two kinds. There are first the compass bearings. Everybody knows the four directions of the compass, okay? North on a map should always point up. East goes to the right, south is down, and west is to the left. And then you can go north, due north, fine. And you can go slightly left or west of north, let's say 20 degrees west of north. So that would be an example for what they call 20 degrees west of north, and written oftentimes in 20 degrees west. And then you can go east of north, right? That's more little off to the right, east of north. You can go east of south or west of south. Let's do an example for that. How about 10 degrees east of south? That's going to go over there. With that tiny angle being 10 degrees, the second example shown is south 10 degrees east, and you read it as 10 degrees east of south. It's a way to specify directions, and mostly going back to either north or south and then slight deviations from them. So of course you can describe directions in different possible ways unless you agree that those angles should always be between 0 and 90 degrees, and then it's unique. Well, there's some examples in the book. Go read them. I'm moving on to the second kind of direction specification, and that's relative bearings. And this is best illustrated with a ship traveling on a straight line. And then they see another ship or a seagull or something. Or the treasure island, I don't know. Let's say a seagull. And now you measure how much is this off from the direction the ship is traveling in. Let's say it's 20 degrees off to the right. And so now you learn a bit of the lingo. The book makes a big deal out of this. In navigation, they call it starboard in ships. nautical navigation. I'm not sure what the pilots do. Aviation, at least on the water, you call it starboard. Starboard means right. 20 degrees starboard. And then to the left, it's called port. So another seagull, 15 degrees to the left would be 15 degrees to port. And this is a reason the ships were actually built so they would always, by default, land with the same side to the dock or the pier, or wherever they unload cargo. So the cranes and the ladders and everything are already in the right place. And that's why they call that the port side, because it's their left side, when you're looking in the direction in which the ship is traveling. All right. So this direction specification depends on the direction in which the ship itself is traveling, and therefore it's called relative. And there's a really good example in the book. Plane A is headed for Ames Airport. And it's 25 miles away. And it has a compass bearing 61 degrees west of north and 61 degrees west, seen from the airport. Then you've got a second plane is 17 miles away. It's also coming to the airport. And it's 29 degrees east of north. What is the relative bearing of plane A as seen from B? Phew, sounds complicated, but let's sketch it. You go to your airport, you go to plane A, you go to due north, it's roughly 60 degrees. I tried, use plane A. This is the Ames Airport. And then you got plane B at 29 degrees east of north. And that's only 17 miles away. So a little less. 17, 25 miles. What we're after is the relative bearing. So given that the plane B is traveling towards the airport, we are looking at this angle. What's the measure of that angle? Call it theta. the measure of theta. It's the angle. Okay, I didn't give a name to that point where the airport is. Can I call that C? So we have a triangle ABC. And we mean the angle at B. So you could call that angle first side, then vertex, then second side, angle ABC. How do we calculate that angle? And this is where a major miracle happens. Because did you notice that I did not mark two of the clues that we're given in that sketch? The clues that I didn't mark are, we have 61 degrees here and 29 degrees there. Well, what does that help? It means that at C we have a right angle. A major miracle. Now the problem is much easier. We got a right triangle ABC, right angle at C, and therefore the tangent of theta is just 25 over 17. Theta is the arctangent of 25 over 17. Yes, it's between 0 and 90, so it really is that arctangent itself. And it's roughly 56 degrees. If anyone wants to check that with their calculator, you should. All right, so all the problems involve right triangles, not the fancy stuff from lesson 9, but they are sometimes elaborate, and you should go and do them with paper and pencil. I'm going to do a couple more in lecture, but for the video tips, I'm thinking that's enough for today. So see you all in lecture.